I'm coming in to talk about why silicon matters in the cloud. And as a cloud services architect and a certified cloud solutions expert, I can tell you that one of the things that I love the most about the cloud is the prolific powering that Intel has done since cloud's inception, right? And the amount of availability of virtual machines, of infrastructure services, of platform services, and even software services that are available to leverage the technology that Intel is powering in the cloud. So one of the things that I feel is important to really relate to people from the very beginning is the scale and the magnitude of which cloud computing. Thor alluded to it earlier in his presentation around 1 billion cores that Intel has provided into the marketplace and to the world to compute and run various workloads. But because Intel has been from the beginning in the cloud and was the first silicon to integrate virtualization technology a few decades ago, or a little over a decade ago, we can provide the right workload performance in the right location with the right level of controls, regardless of the cloud service provider that you're looking to scale and the location that you want to scale to. And again, just to hammer home that point, right? We're in over 100 regions just with these top cloud service providers that I'm showing here, and over 200 availability zones. Availability zones, as most people are aware, are essentially geographically separate data centers to preserve disaster recovery scenarios, right, where it preserves quality of service. And we're available in over 400 countries, not unique countries, but across just these three top cloud service providers. What that implies is that there's over 15 million servers running virtualization technology, and most of those servers are dual socket, as you would imagine. That's about 30 million sockets powering the cloud that are Intel-based sockets today. And again, we're in all of those regions, we're in all of those availability zones in all of those countries. And what that provides me as a cloud services expert and a cloud solutions architect is a very vast palette to draw from, and confidence and consistency and trust to where if I decide to deploy in the East Coast of the United States, I can then leverage into the same consistent Intel cores and compute engines in South Africa or in Eastern Europe, right? And that level of scale, I can tell you as a senior reliability engineer, that is statistically significant to our quality of service and solutions. So another thing that I also want to touch on is, as I said in the beginning, we were there, right? In the early 2000s or near the turn of the century, when cloud started to become commercially available via virtualization technology, Intel was the first to put in VT technology within our silicon. And it makes me feel a little bit older since I've been at Intel about 20 years. I've worked on most, if not all of these data center platforms. And I can tell you from my own experience working within Intel as an engineer and as a product manager that Intel is consistently focused on innovating for cloud, whether it's offloading or making the vast amount of or proliferation of encryption for data at rest, data in flight, and application execution with accelerating crypto or crypto acceleration, I should say, as well as today, right, as we get into this decade, we've really focused heavily on application performance or real world workload impacts when it's in a highly scaled, highly virtualized environment. So I think these are all very important things to note, that when the cloud service providers in the days of this pandemic, right, look to scale their supply lines and look to scale their cloud services because of the increased demand, we were glad to be of service of them and help them in meeting those needs and those demands, and and the value that people come to their clouds for in elasticity and scalability, Intel was able to partner with them and help deliver on that promise, even in trying times like this pandemic. So one of the things that all of this several decades of innovation has driven is a breadth of product technology and product offerings to service both the public cloud service providers as they've come online and have scaled and ramped, but also the private clouds as they have developed. And it really helps us, that consistency of computing platform really provides a great platform for hybrid cloud and multi-cloud environments as well. But that consistent asserted innovation effort that we've tried to do at Intel has really developed this breadth of portfolio that allows people to, starting with the outgrowth from the Xeon processor, right, into these other platforms that help from edge device computing or from a storage perspective, right, from our heritage and memory, as well as in the networking space, right. The other thing that I always want people to understand and be aware of is Intel is producing its best silicon ever, right, with the Ice Lake launch, right, yesterday. We take that approach because we then follow it with ecosystem optimization on top of that silicon and that software, right? And so you're going to hear it in this presentation a lot about how we have taken existing, available, consistently performing silicon that's available as infrastructure as a service or platform as a service or software as a service, and will apply or will take advantage of the available performance that comes from utilizing the primitives in the microcode or the instruction sets that we introduce gen over gen over gen consistently. So, sorry about that. Why does Intel matter to Microsoft is a great case study in this example of the breadth of portfolio as well as some of the things that Microsoft takes advantage of within Azure, right? Azure is an Intel-powered cloud service provider, a very great partner of ours. And in that, they utilize the Xeon platform or Xeon processors, right, to a great extent, but they also take advantage of our FPGA offerings as well as our SGX for Azure Confidential Computing services. They use our FPGAs within the SmartNIC configurations, which then enables more agility to use those SmartNICs, one for optimizing their networking traffic, but also to then utilize for artificial intelligence and reprogram them to do image analytics or defect detection and learning arrays, right? They also take advantage of our persistent memory for much larger footprints for in-memory database computing like SAP HANA, some of the other services that they then provide. They have virtual machine instances or bare metal virtual machine instances that take advantage of such a large memory footprint and then accelerate those database analytic queries. They also take advantage of our silicon photonics, and Microsoft and Intel together have really embraced the open source machine learning frameworks and libraries to take advantage of those, and they're absolutely a great leader in this space at this point. What does that translate into to the consumer? And that's the most important thing for both of our companies. And that is, as consumers come to do general purpose workloads or compute optimized workloads or memory optimized workloads, there's a whole breadth of technology and virtual machines that's available at the touch of a button or on a subscription basis, right? And so we've looked at a lot of those recently, right, as we want to showcase that flexible performance that we're now bringing in greater fold with our third generation Xeon scalable processors. When we look at the virtual machines and how Microsoft expresses Intel's technology via their virtual infrastructure, we can start seeing greater IOPS for read-write into the local storage. We can see greater performance as found within the frequency targeting series or the high performance computing virtual machine families within Azure. Obviously, HPC starts to talk about a lot more vectorized processing, which then takes advantage of AVX 512 and some of the other vectorized primitives and extensions that we build into the Intel Xeon scalable processors. And they start seeing 2x the performance just by choosing the right virtual machine. And those machines, as I said earlier, are available throughout the world, right? So they can move that workload wherever they need to have it, closer to the consumer or the data sovereignty requirements, and still trust that it's going to perform and perform very well. That's why silicon matters so much to Microsoft, but also to all the cloud service providers in general. It's the same or a similar story and a similar findings, and I'm going to show you why. In the memory space, right, obviously, in the memory space, you start talking about relational databases or in-memory database computing. We see as much as 50% performance gains, right, with the MV2 series or the EDV4 series, right? And a lot of this is due to, in part, to it being powered by the Intel Xeon scalable processors. Another thing I wanted, this is a bit of an eye chart, I apologize, but I wanted to share the depth at which Intel technology provides for diversity and breadth of workloads, right? So you can see all the various targeted workloads and all the various Azure-based virtual machine series that are available to the customer in a cloud fashion, that they have a lot of the Intel-based technology built within them, right, and enabled within them, as well as breadth of memory capacity and bandwidth and CPU core range sizes, right, to cater to the workload. A lot of the questions that I heard earlier really are dependent upon how that workload is handled from the virtual machine that is expressed within the cloud service provider. And most of the time, that cloud service provider or the consumer is tapping into infrastructure and compute engines that are powered by Intel processors and technology. So what does that mean, right? Ultimately, what that means is that Intel-based cloud workloads, right, offer a performance and a value that is second to none, right? In that it's consistent, it's available, it's scalable, it's elastic, right? And just by choosing the right latest and greatest virtual machine that's based on the latest generation of Xeon scalable processors, customers can realize better query performance in their SQL analytics, whether it's analytical querying or transactional throughput, right? We've tested and we're running proof point series around how flexible the workloads are on these cloud service providers, virtual machines, or infrastructure as a service. You can get twice as much, up to twice as much scale out performance from an Oracle database. Virtual machines running VMware as the orchestration engine can see as much as twice as much throughput. And then WordPress, which is similar to Nginx as far as web service transactions and website traffic, you can see as much as 50% gains. Again, just by choosing the right virtual machine, right? This is something that, it's 3 or 4 clicks for the consumer to choose. Now, here's where the strategy of Intel saying, hey, our best silicon is in front of us and there and offered and available. We then go in and work with hundreds, as Thor and others have mentioned earlier, we work with hundreds of different ISVs and companies to optimize their code, or we work and help the cloud service providers offer industry-specific code optimizations, right? Whether it's through one API or other application layers, runtime. In the cloud, nothing is static, nothing stays still. And so once you've chosen the right virtual machine, immediately the consumers, right, they start looking to optimize and maximize their subscription or their service fees that they're paying, right, to the cloud service provider. And so this is really just showcasing the exponential gains that you can get by taking that next step and continuing to maintain your desire to maximize your service level and your service subscription fees. And Intel delivers in those spaces, again, throughout the world, when it comes to faster, in the case of faster high performance computing for financial services, and Ram talked quite a bit about it in the previous hour, so I'm not going to spend a lot of time on it, but we get up to 30 times faster, better performance, either gen over gen, again, from a processor core or a vCPU that you can get anywhere in the world consistently. So one of the things that we're doing is we're going through and we're testing.
Joe, can I ask one question? So from
Absolutely.
a customer's perspective, how do you help the customers leverage what you're saying right here? So from me as a customer, I'm going to a cloud provider. What is Intel doing helping me to take advantage of getting the best VM that I need for the workload that I have?
So there's a lot of different things that we do. So one is first and foremost, right? We work with the software vendors, right? In the case of platform services, to optimize the VM that is used or the infrastructure that's used. So even before, because the cloud is about scalability and elasticity, less about digging through the things unless you're doing infrastructure as a service. So the first thing we do is with the software vendors, we develop and help them develop on our architecture. And most of these software vendors are actually architected with Intel Xeon processors from inception or from concept, right? Hasso Plattner, the founder and of SAP, right? He architected SAP HANA to run on Xeon scalable processor 15 years ago. So that's the first one, is we go behind the curtain first of all and say, hey, you don't need to go into the nitty gritty or thousands of lines of code to optimize it, but we will with these ISVs. We then also go out to the global solution integrators, right, who customers are utilizing to scope and then phase in their service transitions, whether it's migrating from one cloud to another or migrating from their private cloud to a public cloud. We work with those global solution integrators and help them to understand the benefits, right? We work with the cloud service providers themselves to help them determine, hey, which primitives, like turning on hyperthreading, which has been around for, I think, 13, 14, 16 years-ish. Hey, for high performance computing, sometimes you do want to turn off hyperthreading to control or manage the threads and what's going on within the compute engine. We work with the cloud service providers to provide those options based upon the workloads that they're targeting, as well as the families that they're introducing and the purpose of those families and which workloads they're optimizing those virtual machine families or instance families to work from. So those are, we try to build in those recommendations as much as possible, but then we also then want to share that, hey, some of this performance is very much workload specific, right? Very much application specific. And then we also try and provide the code, the one API features and function to the marketplace there.
One of the challenges that customers have when they use resources in the cloud is maximizing utilization of those resources, right? You kind of touched on that a little bit. Even if they do kind of get into the nitty-gritty of it, there are so many different configurations and options, even within a particular instance type or resource type. Is there an opportunity? And I know there are solutions that are coming onto the market and are on the market that will kind of help guide you down that path. But I'm thinking about this from the other direction. Is this an opportunity for Intel to provide some guidance to the CSP or to the customer in terms of, hey, this is a way you could more efficiently use this resource? I don't know, I might be spinning philosophical here a little bit, but it would be an interesting exercise.
You are a little bit, but we are philosophically, we desire to be in that space, right? So that's one of the things that I'm showing here even on the screen. So it's a great question. And Keith, I know you also had a question, so I will come back to you. The key thing there is most of the cloud service providers and Intel are trying to understand the workloads that are taking place. And so in that way, what we're doing is we're going through and testing some of the most prevalent categories of workloads, right? Databases, web services, analytics services, right? On that data, either streamed in or on the database themselves. And then of course, artificial intelligence, which has been talked about dramatically. So The hard part there is that there are thousands of permutations of virtual machines for each CSP, and there's hundreds of CSPs, including the top ones that I'm showcasing here. So the tricky part is, and all of which are consumed not on an annual basis like traditional servers, which are purchased over a 1 to 7 year period and then deployed. They're purchased by the second or by the hour or by the day. And so part of what we do is evangelize the great features that we have that are available throughout the world, so that the customers then start asking for those features, and they know to ask, because the CSPs, even with their permutation of virtual machines, can't make them specific. And if they do, they start forming up platform services, right, instead of infrastructure services. So there's a whole bunch of dynamic pushing and pulling that takes place to make sure that you're maximizing the utilization of the compute engines that you are subscribing to, but also then taking advantage of the code optimizations depending on your ISV or your application and your workload needs. So I can't answer your question, obviously, Tim, very specifically, because it's borderline philosophical, but we're working on all fronts, in the sense that we're working with the software, we're working with the cloud service providers, we're working on the architecture, we're working within the ecosystem to make people aware of these great technologies that we're building in, right? And today is a great example of evangelizing that.
Thank you.
Talking about the OEM relationships and the cloud partner relationships, a few weeks ago, the team presented at Cloud Field Day 21, I think, on telemetry data and the ability to kind of get these low-level performance metrics off of processors. Because, quite frankly, a problem that we run into in the enterprise is that a Intel scalable third-gen Xeon scalable system, same processor or close to same processor. One cloud provider performs differently in one region than it is in another region because of various elements, most likely noisy neighbors.
Sure.
How are you guys helping beyond kind of giving customers that raw data? Can you talk to kind of the relationship with ISVs? There's like a half a dozen of these performance monitoring services companies out there that help us with noisy neighbor problems, but servicing up that data, not just the data, but the end results Tim talked about, which is, am I optimizing for in one system, in one region, as I am in another region, or C2, C3, take your flavor?
So again, great question, and you're asking how our silicon features are expressed by each individual cloud service provider, and then how does the end customer cut through or part that curtain that may be veiling some of the telemetry features that we have built in, right? So hopefully, I wasn't able to attend that field day, but hopefully they talked about not only the scalable processor built-in telemetry and the node level telemetry and the cluster level telemetry, as well as the automated closed loop orchestration of those containers. But each cloud service provider, and by the way, each OEM, if you're working within a private cloud environment, has the option of veiling or expressing those telemetry options to prevent things like noisy neighbor, or in some cases, right, prevent overselling too much performance, believe it or not, with like speed select or some of these other features that it's demanded by one neighbor and not by the other, but the other, because one demands it, it's turned on, and the other receives a frequency bump or a greater throughput because of one neighbor's benefit to the other. So it's not always negative, it's not always positive. Each cloud service provider, you start getting into load balancing features and opportunities, as well as networking, storage, and regional data sovereignty requirements associated with it. So I wish I could answer the question better for you, Keith. It's a great question. It's very CSP specific and OEM specific. We do extensively work with them prior to general availability of the virtual machines to help prepare them for what the marketplace demands will be for this type of telemetry data. There are obviously scripting ways and language within the shells to go and get some of this telemetry data. But again, it is also dependent upon what that shell provides within that specific CSP. That's the best I can answer for today. I am cognizant that I'm about a little bit over time. So in the last 3 minutes, I want to really emphasize, I also want to emphasize that, you know, Amazon and Google also offer and express their cloud instances that are powered by Intel, and they are just as broad and they are taking advantage of a lot of the technologies in the case of AVX 512 and Deep Learning Boost. Again, all of this is by public demand. In the cloud, everything is very much a pure market in that most features are expressed based upon end user demand for those different features and technologies. And they are demanding Intel powered by millions, right? Again, we've already talked about once you've chosen the right virtual machine, there are things that you can do to find out and get more performance and better utilization and load balance your solution for your customer. It's also more than just saving money as well. We know this from not only the research that we've done, but we build that. That's why we've built in trusted hardware technologies, right? Like software guard extensions and SGX, like DL Boost, is because the cloud customer base, we hear it consistently, demands higher levels of agility, higher levels of employee productivity, greater diversity of services. Most people come to the public cloud because they need the disaster recovery, they need the migration. And then they discover that the cloud offers unique and novel services like artificial intelligence, like greater levels of security that they couldn't get without significant investment on their part. And they can turn it on by clicking a button or building it into a new level of service or employee productivity. Intel provides the technology for those new services, which increase the greater consumption of cloud services overall, and that's what leads us to cloud scale computing. Greater scalability, greater reliability, right? That was the first point that I made is, hey, having a greater availability, scalability, and reliability. But the other thing that we're also remembering and why we're doing workload-specific expression of Intel-powered virtual machines is that customers demand that performance, right? It's not just about getting the most efficient performance, but getting the best performance for their workload to get their work done as possible. So again, the key points here is we work with hundreds of ISVs and have for over, in some cases, over 15 years. We provide the most trusted technology for all the major cloud solution providers, as well as with Oracle, SAP, VMware. I mean, VMware Cloud is only on Intel architecture. That's how trusted it is. And we also are serving as the foundation for like appliance-based, as well as cloud ingestion management software like Google's Anthos or Azure Stack, right, or Azure Arc. Some of those things we serve as a trusted engineering venue for. I don't need to spend too much time because we've already spent a lot of time on artificial intelligence, but again, that drive for innovative cloud technologies, and Laura is also going to spend, unfortunately for her, 20 minutes on confidential computing, but we've talked on both of those. But I want to come back to Pat Gelsinger and his positioning, right? Once you've chosen an Intel-based virtual machine to continue the decades of success in the cloud, cloud and cloudification, and the reason it's so important that it's based upon a quality, consistent standard is that that cloud serves as a foundation for 5G, for AI, for edge computing, right? Even if it's with a third generation Xeon processor. So appreciate you guys sticking with me. I think you can tell this is very exciting to me, even after 20 years at Intel. This is the best yet.